Question 8. A horizontal jet of oil with density ρ exits a nozzle of area A at speed u and strikes a vertical metal plate. The jet spreads out along the surface so that it loses all horizontal momentum upon contact. The volumetric flow rate remains constant. Determine the magnitude of the horizontal force exerted on the plate by the oil jet. This problem tests our understanding of momentum in fluids and the application of Newton's second law to continuous jets. Before we get into the main solution, let's recall the relevant concepts. We know that a moving fluid carries momentum, and whenever its motion changes or stops, a force must be exerted to create that change. We also know that when a fluid jet hits a surface and spreads out, it loses all momentum in the direction normal to the surface. Finally, we know that Newton's second law tells us that force equals the change in momentum per unit time. Let's dive into our main solution. We know that the force exerted on an object is the rate of change of momentum, given by the equation F equals delta P over delta T. For simplicity, we'll choose a time interval of delta T equals 1 second, so the force is simply equal to the change in momentum during this time. F equals delta P since delta T equals 1 second. Now let's figure out the momentum change step by step. The distance traveled by the jet in 1 second is given by u times delta T, which simplifies to u since delta T equals 1 second. Next, we calculate the volume of oil hitting the plate in 1 second. The volume is the area of the nozzle times the distance traveled by the jet. So, V equals A times L, which simplifies to V equals A times U. Now we need the mass of the oil hitting the plate in 1 second. The mass is the density times the volume, m equals ρ times V, which simplifies to m equals ρ times A times U. Now, let's calculate the incoming horizontal momentum of the oil jet. The momentum is the mass times the velocity, so we have P in equals m times U, which becomes P in equals ρ times A times U squared. After the oil jet strikes the plate, it loses all horizontal momentum, so the final momentum is 0, P final equals 0. Now we calculate the change in momentum, which is the final momentum minus the initial momentum. Delta P equals P final minus P in, which becomes delta P equals 0 minus ρ times A times U squared, which simplifies to delta P equals negative ρ times A times U squared. Finally, we calculate the magnitude of the average force. The average force is the magnitude of the change in momentum divided by the time interval. Since we chose delta T equals 1 second, this simplifies to F equals the absolute value of delta P over delta T, which becomes F equals ρ times A times U squared. This is our final answer. What did we do? We wanted to determine the magnitude of the horizontal force exerted on the plate by the oil jet. We started by calculating the momentum of the oil jet before and after impact. Then we found the change in momentum and divided it by the time interval to calculate the average force. Job done. Let's summarize. The jet loses all horizontal momentum on impact as it spreads along the plate in any direction but horizontal, so final horizontal momentum equals 0. The force on the plate comes from the horizontal momentum removed from the jet per second. Using delta T equals 1 second simplifies the calculation, giving F equals ρ times A times U squared.